You're welcome at Medical Sciences. And in today's session, we want to look at the structure of glucose, which is the most monosaccharide sugar. So I want to see how it looks like according to Fisher and Haworth projection. And as we begin, we always remind you to subscribe, like the video, and share your comments. And glucose, the structure of glucose, according to Fisher said that glucose, according to Fisher projection, that glucose is a linear structure. Whereas Haworth projection, he says that glucose is a cyclic structure. It is cyclic, or it is ringed structure. And we know that glucose is made up of 6 carbon, whereby this is carbon number 1, number 2, number 3, number 4, number 5, and number 6. This is 2, 3, 4, 5, and 6. And here we have the hydroxyl group. So this is the structure of glucose with the 6 carbons. And as we see that Fisher says it is a linear structure made up of an aldehyde functional group. And then we shall call this one D-glucose. Why do we call it D-glucose? It is because the hydroxyl group at carbon number 5. When the hydroxyl group at carbon number 5 is on the right, we call it D, and when it is on the left, we call it L-glucose. So when we go to Haworth projection, who says it is a ringed structure, it says the hydroxyl group at carbon number 5 interacts with the functional group at carbon number 1 of glucose to form a 6-membered structure, to form a 6-membered ring. And this 6-membered ring formed whereby the hydroxyl group or the alcohol at carbon number 5 interacting with the aldehyde at carbon number 1 is what we say as 6-membered ring, known as glucopyranose, whereby pyranose comes from the word pyran, which means a 6-membered structure. And as we move on, these two projections, they suggest that whenever monosugars, whereby the hydroxyl group on the same molecule interacts with the carbon number 1, they form either hemiacetal or they form hemiketal. So they can either form a hemiketal or hemiacetal when the hydroxyl group reacts with the aldehyde group. So when it reacts with an aldehyde group, we form a hemiacetal when it is an aldehyde group, and hemiketal when it is a keto group, for example in fructose. So as we are seeing, the hydroxyl group is interacting with the carbonyl group. We form a 6-membered ring, whereby this 6-membered ring, if the hydroxyl group is above the plane, we call it beta. When we draw the plane, and we find the hydroxyl group on carbon number 1, which we call as anomeric carbon atom, we call it beta glucose. This one becomes beta glucose. Why? Because the hydroxyl group at carbon number 1, which is an anomeric carbon atom, is above the plane. And if it is below the plane, that is alpha. So we are going to see that here we shall have hydroxyl group, then the hydrogen, then hydroxyl group inside after forming. So as we are seeing, after interacting, it curves, or it forms a ring, and this is the ring that we form from this linear structure, whereby we form a 6-membered ring. For this But when the hydroxyl group at carbon number 4 is the one interacting, the 6-membered ring is formed at carbon number 5 interacting with the carbon number 1. So this one is formed whereby carbon number 5 hydroxyl group is reacting with aldehyde at carbon number 1. But in case the hydroxyl group at carbon number 4 is the one that is reacting with the carbonyl group at carbon number 1, or the aldehyde group, this one will form a 5-membered ring. This one will form a 5-membered ring, and this 5-membered ring is known as glucofuranose, whereby furan means 5-membered ring. So this is a 5-membered ring, this is a 6-membered ring. 5-membered ring formed whereby the hydroxyl group at carbon number 4 interacts with aldehyde at carbon number 1. So there we form a 5-membered ring feature. But as we move on, we shall tell you that the anomeric carbon formed at carbon number 1, we shall regard it as the chiral center. So something to note in this session is that we form the chiral carbon, or what we call a chiral center, whereby a chiral center is whereby we find the carbon, one carbon surrounded by 4 different functional groups, whereby at this stage we are seeing the carbonyl group, the oxygen, then here we have the hydroxyl group, then here we have the hydrogen, and here we have carbon number 2. So we are seeing carbon number 1 surrounded by 4 different functional groups, and that is what we call a chiral carbon. So this one, carbon number 1, is known as, is regarded to as a chiral carbon. Why? Because it is surrounded by 4 different functional groups. So it is called a chiral carbon, or you can call it a chiral center, formed during Hauth projection. So in summary, as we are concluding at the structure of glucose, which we have seen, it has 6 carbon atoms according to Fischer, and it is in linear structure. Then Hauth projection says if the hydroxyl group at carbon number 5 interacts with aldehyde group at carbon number 1, we form a 6-membered ring, which is glucopyranose. And when the hydroxyl group at carbon number 4 interacts with carbon number 1, the aldehyde group, we form a 5-membered ring, which is known as glucofuranose. And that is what we can talk about it. And we have seen that when the hydroxyl group at carbon number 5 is on the right, we call it D-glucose. And when it is on the left, we call it L-glucose. And when we went on the ring cyclic structure, we said when the hydroxyl group on carbon number 1, which is an anomeric carbon atom, or the chiral carbon, if it is above the plane or in the same direction with hydroxyl at carbon number 6, it is known as beta. And that's why you normally see when we are writing beta, we go up. So how I know is that when I'm writing beta, I go up. So for a beta glucose, the hydroxyl group is above the plane. Then for the alpha glucose is whereby the hydroxyl group, for example, this one is alpha glucose or fructose. Why? Because if I draw the plane, the hydroxyl group at carbon number 1 is below the plane, or is in the opposite direction with the hydroxyl group at carbon number 6, and this one becomes alpha glucose. So alpha and beta anomers are seen in ringed structure, whereas D and L series are seen in linear structure. Thank you so much for listening. Always remember to subscribe and share your comments with us. Thank you so much.